Hello dear friends, and welcome to another episode of this factorization series. Today we are taking a look at application of factorization in other topics. Now in higher topics, we're going to be considering some little bit advanced mathematical topics in higher institution, maybe around degree 1 courses. I believe you've been following well all the series we've had prior to this time. I believe you are interacting well with them and you are enjoying them. So I want to use this time to send a sincere apology for not being able to upload content in the last 2 weeks. So don't worry, I'm going to cover up for those 2 weeks. Don't worry, I'm going to cover up. And very soon, maybe by next month, we're going to be having 2 videos uploaded per week on this channel, just to meet up with the demand of the audience. Welcome again. Here is application of factorization in other topics. So here we'll be taking unit 3B. This particular videos can lead us to 3C, probably to 3D. So I'm looking forward to having 3 to 4 videos before we can, solve the work we are having here. So just this question 1 and question 2, but they take a lot. They are not hard. See how we need factorization in getting this work done. I believe we are ready for the class, and I will be with you in a moment.
There's no other lover like you, Jesus, Master Lover, Jesus.
Alright, see you, welcome back. We are going to be seeing the place of application in solving this work. Now, question 1. Express the following, that is, Roman figure 1, 2, 3, and 4. Express them in terms of A, B, and C, provided that alpha plus beta is equal to minus B over A, and alpha beta equals C over A. We're going to be doing 1 to 4, and in doing these 4 questions, it may take us 3 videos. Yeah, 3 videos. It's not because they are hard, but I just try to use many approaches in getting this work done. Alright? Don't let me waste our time. Let's dive directly into the work. Now here we have question 1. Question 1 says, if alpha plus beta equals minus B over A and alpha beta equals C over A, then express alpha squared plus beta squared in terms of A, B, C. That's the question. Maybe we'll go back there. Okay, you want to express alpha squared plus beta squared in terms of A, B, and C. So what does that mean? It means that you're first going to express this value such that every term in your expression will conform to alpha plus beta and alpha beta. I say that again. You want to find this value, alpha squared plus beta squared. You want to find the value of alpha squared plus beta squared such that every term in your expression will conform to alpha plus beta and alpha beta. That is what we want to do. And that's the same thing we want to do for every other question in this question 1. I believe you're following. So let's move on. Let's express alpha squared plus beta squared in terms of alpha plus beta and alpha beta. Then we can later do substitution. Now I want to say, please permit me to use this sign as alpha in this lesson. Although I know it's proportionality sign, but anywhere I'm referring to it in this video, for the sake of this video, permit me to refer to it as alpha. I think I'm permitted, please. I think I'm permitted. This is proportionality sign, so please don't hold me responsible. Okay? Alright, so what do we do now? The approach to it is, you think of what expansion you can do that you will be able to have an alpha square and a beta square. That's the first approach. What kind of expansion can you do that will be able to get the term alpha square and beta square? So the first thing is, think of how to square this particular value, alpha plus beta. So as I've brought it out here, so let's just square it. The value is already squared, and that simply means that the value is going to be multiplied by itself. That is the implication. Alright? Such that by the time you expand, your first term is going to be this alpha multiplied by this alpha. You're going to be having an alpha square. And the last term of your expansion is going to be this plus beta multiplied by this plus beta. You're going to be having a plus beta square. Don't worry, you understand by the time I'm done with the work. So let's see. By the time I expand this, by the time I did this expansion, I have a video on this type of expansion. So I'm going to be suggesting it in the description box. Please get there and check out. So here is alpha square and here is beta square plus beta square, which is what I want to achieve. So expanding this, I got this. Alright, so now what's the next thing I'm going to do? Let me bring down what I'm having there. So the next thing I'm going to do is that I'm going to bring out the two terms I'm after. So this is an alpha squared and this is a plus beta squared that I'm having on this other side of my equality sign. Then what else do I need to do? This is the value I'm looking for, remember? Then I'm having plus 2 alpha beta, which I will need to separate from all the terms on this side, and I would need to bring it to this side of equality sign. I believe you're getting what I'm doing. Okay, now this is alpha squared down here. This is beta squared down here. And it's alpha plus beta squared, all squared here. And this is equality sign. Now a term is still missing, which is this term. I don't want it on this side of the equality sign again. Rather, I want it on this side, such that this value I'm looking for is already made the subject of the formula. So bring it down here. I've successfully brought this down here. Now this sign has crossed. This is a plus 2 whatever. Now since the value has crossed this equality boundary, what is going to happen? It won't remain the same sign again. It's going to change, and that is a change to negative, just like you can see it on your screen. It's a normal rule in mathematics. So with that done, have we been able to achieve what we want to achieve? Let's look at it. Here is alpha plus beta squared, and here is minus 2 alpha beta. Remember, I said the other time that by the time you are done looking for this value, every term, every bit of terms in your expansion or in your expression must conform to either alpha plus beta, the one you have here, or alpha beta, the one you have here. So looking at what I've done here, have I achieved that? Of course, yes, I've achieved it. This is alpha plus beta, though squared, but it has conformed to this already. And this is alpha beta, though it's having a coefficient of 2, but it has conformed to this already. So I can easily substitute the value, this value, minus b over a for alpha plus beta, and I can easily substitute c over a for alpha beta. Okay, let's see how that works. So if alpha plus beta is equal to minus b over a, and alpha beta equals c over a, then what happens? I can now say alpha plus beta, alpha squared plus beta squared equals alpha plus beta in bracket squared, then minus 2 alpha beta. Now, doing the work I'm assigned to do, to express alpha plus beta in terms of these values, minus b and abc. So it means that for my alpha plus beta, I will be having a minus b over a, then have it squared. I believe that is understood. Instead of writing alpha plus beta now, I'm writing minus b over a. Then minus, instead of writing alpha beta, right now I'm having c over a. This c over a. I think that is clear. Instead of writing alpha plus beta, I'm writing minus b over a because that's the value of alpha plus beta. Then, because I'm having square here, I need to square it. Now instead of writing alpha beta, I'm writing c over a, because that is the value with which it is represented here in terms of ABC. Let me move further. Now, if I am given a quadratic equation that involves A, B, and C, I can easily substitute in my values here. Since I know my A, since I know my B, and since I know my C. Now, I referred to a few video the other time on expansion. In the same video, I treated coefficient of terms. how to get what is the value of your A, your B, and your C in a quadratic expression. Please get that video, and by the time you get it, you'll be fine with what we're doing here. Okay, let's proceed now. The second question says find the value of alpha cube plus beta cube, or better said, alpha raised to the power of 3 plus beta raised to the power of 3. The same thing is, by the time you're done expanding or expressing, you must get every answer conforming to alpha plus beta or alpha beta for you to be able to do your easy substitution. Remember, you are not expressing it in terms of alpha and beta, you are expressing it in terms of A, B, and C, like the format of a quadratic equation. So let's see how it works. Now, I am writing out these, and you know, this mathematics, I don't want us to just keep our head in just one box. There are many approaches to this thing. Probably 2 approaches. So the first approach is by doing a binomial expansion of alpha plus beta raised to the power of 3, all raised to the power of 3. Or by saying alpha plus beta in a bracket multiplying alpha squared plus beta squared. Now, by the time I'm done doing this expansion, I will have my first term to be alpha raised to the power of 3, and I will have my last term to be beta raised to the power of 3, which I'm having here. That is what is prompting me to do this. And here, by the time I'm done doing this expansion, this is an alpha multiplying an alpha squared. Of course, that's going to be giving me an alpha raised to the power of 3. Now, this is a beta multiplying a beta squared. That is going to be giving me a beta raised to the power of 3. So, either of these, I'm going to get my answer. Let's move on and let's make use of this first approach. So now I want to do a kind of binomial expansion. Okay? Where we'll be needing a Pascal's triangle. I believe you've heard that before. Maybe you're not very okay with that term. We'll get there very soon. Let's go and do Pascal's triangle. Alright, this is a binomial expansion when x plus y is raised to the power of n. Okay? Now, we are going to be constructing a Pascal's triangle where we'll be starting with 1 here. Okay? So this one connotes the value of this expansion when n equals to 0. Remember, anything equals to, when n equals to 0. Remember, anything raised to the power of 0 is 1, isn't it? Yes, it's 1. Now, the next line will be considering the value of this, the coefficient rather, of this expansion when n is going to be equal to 1. And that is going to be 1, starting with 1, and again ending with this one. Alright? This is when the value of this n equals to 1. Alright? Of course. Now, the next line is, we'll be considering when the value of n equals 2. So we'll be starting with a 1, but now we'll start doing addition. So starting with a 1, the next thing we'll do is, this 1 added to this 1 gives 2. Then we're done with the addition. We also end it with a 1. Okay? Now, when n is equal to 3, okay? When the value of n is equal to 3, we want to write out the coefficient of our terms. So what happens? We're starting with a 1, always starting with a 1. Now, this 1 added to this 2, let's start addition now. 1 added to this 2 gives 3. This 2 added to this 1 gives another 3. Remember to always end with 1. Start with 1, end with 1. Then when n equals 4, yes, when n equals 4, here is when n equals 0, when n equals 1, when n equals 2, when n equals 3. Now n equals 4. Now when n equals 4, you start with 1, then let's start our addition. 1 multiplied by 3, 1 added to 3 is 4. 3 added to this 3 is 6, and this 3 added to this 1 is 4. You are ending it with another 1. Now, when n equals 5, this 1 added to 4 is 5. This 4 added to 6, that's 10. This 6 added to 4 is another 10. And this 4 added to 1 is 5. please try and end it with another 1. It's starting with 1, ending with 1. Sorry, are we forming a triangle already? I think yes. Now the last one is 6. Okay, I won't have time to do that 6 for us. It's just following the same principle. Starting with 1, do your addition, then end it with 1. The same thing for 7. Okay, now remember we are dealing with a work where our n equals 3. Okay, so where our n equals 3. So this is when our n equals 3. So let's bring out a bar that comprises all the coefficients of our binomial expansion when n equals 3. And now let's bring it to, now we're back on this page. I think we're taking too long a time on this video. I would love us to just proceed in another video so that I won't need to bore you with a long content in this video. Remember to like this video. If you have not subscribed, do punch the subscription button and try to hit the notification bell. Just join me in the next video. That's going to be in a 3C. Okay?
When I remember just how you love me so, I got the wisdom to love all my enemies so. When I remember